Hello everyone, my name is Quỳnh Lam, Quỳnh Lam ha, and I would like to go over April 2. April 2 today. Let me open up the PowerPoint. So this is April 2 hypothesis testing in 4 steps. So for this section, you will learn how to conduct a hypothesis test involving a population proportion. And I would like you to look at this slide. So it looks like A.1, but for the section A.2, they kind of more specific and showing you step by step more clearer than A.1. A.1 is look like the introduction only. So this will be the step. It's look a lot of wording. However, like when you jump to the actual example, you will see it easier. So the next, so here is the condition to test. Actually, for this slide, talking about the condition that you are testing before you can compute z value. So this like a subcondition right here is from step 2. Step 2 is prepare, right here, prepare. So this condition is in step 2. However, when you do on your test, you don't have to worry about this step. I don't need you to write this whole things in, but you only need to identify the hypothesis test, right tail, left tail, and you can jump to find z value and the standard error, then p-value, and then you draw a conclusion and you interpret the test. Here is the example. This example about death penalty. So let's take a moment reading this. So right here they're saying that in 2019, it was estimated that 63% of Americans supported the death penalty. In 2014, there's a poll found that in a random sample of the total is 943 Americans, about 538 supported the death penalty. So this 558 here, this data, we call this a success, the total of the success. And 943 is the total of all Americans, or the total of the, or another word, that would be your N. That's the sample size of the total of the people who they're kind of asking if they support the death penalty. And the question is, do we have evidence that support of the death penalty has declined amongst Americans since 2009? So this here in this question, there's another keywords that you can see right here, telling you you should apply the left tail test, because the word has declined right here, telling you it's decreased, right? So will be the left side area. So you can run a StatCrunch for this one. So when you run StatCrunch, you will enter this value 538 for the number of the success, and this will be the total of number of sample size, and you will need to enter this p0 value right here to run StatCrunch to get the probability or p-value, and then from there you will compare the p-value with alpha, which is the level of significance. Right, in this example, they didn't tell you the level of significance, but actually the level of significance usually would be 1% or 5%. So if I assume this a level of significance is 1%, then let's see when we run StatCrunch what the p-value that we're gonna get. So here it will be the specific steps. So step 1, hypothesize. So you need to state the null hypothesis and the alternate hypothesis. And look like our P naught is 0.63, which is 63%. So you have to write exactly like this. H naught colon P equal to 0.63. And the alternate hypothesis is like this, because the word support has declines, right? So you need to write the less than notation, and you need to write HA colon P less than 0.63. So this step all the time will be need to be right on your work. And step 2, prepare, is the condition, the 4 condition that I showed you previously. Previous slide. For this one, to me, my personal, I usually when every problem, when we give it to you, this step, prepare, already satisfied. So to me, I don't force you to write this step, but you are welcome to write extra. You still get full credit if you don't write this step. And then step 1, then you can jump to step 3. For step 3, compute to compare. You need to find the sample proportion, which is p hat, that you notice right here. In order to find p hat, I take the number of success 538. I divide it by the total of the voters right there, and I have p hat is 0.5705. This value, I call this will be the observed value, observed data. So if you're using compute by hand, then you have to apply the formula as below. So for the standard error, which is SE, equal to the square root of P naught times 1 minus P naught, close that, divided by N. So when you replace the number, you will have this value. And the SE you found is 0.0157. Now you're going to plug this into the Z value, the Z test statistic. You will have P hat minus P naught and divided by SE. SE you found above here. So you plug in, you have negative 3.82. So right here, this value is unusual, is why. So when we're talking about the normal bell shape, remember normal bell shape that you learned from chapter 6, 6.1, 6.2, the maximum that you can see the standard error is 3 standard deviation away, right? And then a small part to the right and to the left. So this is beyond, this is larger than we expect. So if we are finding the left tail for this one, so the probability will be unusual. So in the practice, we usually use technology to compute to test the statistic and the p-value. So you will have 2 methods. The first method, you use the table, but right now you don't need to worry about a table because you already bought the StatCrunch. So you just run StatCrunch, you got the value and copied it down. So you don't need to worry about TI-84 or using the paper table anymore. And but if you would like to, then you can ask me for help. But I suggest that you use StatCrunch for this class. And when you run StatCrunch, we end-to-end. So later I will do it for you to see it. You put the data in, and you will have the value is for x is less than negative 3.82. You will get the p-value or probability will be 0. So let me go back to the previous slide to see the data that we found right here. So right here, you found a negative value, 3.82. So this number is supposed to be on the left side, right? Far away from the 0. And it's like, we're talking about the left tail. Let's go back to this, step 1. This is the left tail. It means like the graph will be all the way to the left, which is nothing. which is 0. So that's why when you compute, you got p-value is this. Usually we will route to 100 place or 1,000 place. So if even a 1,000 place or 100 place, the p-value will still be 0. So we run StatQuant. This is will be the step to run StatQuant. What do? You go to StatQuant stat and go to proportion stat and go to one sample with summary and you click compute, you will have this value. So let me run this for you. So I open up my stat lab, my stat lab. I will log on. I sign in my account. You go to your account. I go to my account. Then you go to StatQuant. So right here we have data set from your textbook. We don't use data set from the textbook, but we can use the StatQuant website to compute by entering our data in. Okay. So let me sign in one more time. Now I open StatQuant. So when you open StatQuant, you go to stat, right? And you go to proportion stat. You go to one sample with summary. You click that. And here you make sure you enter your data. So let's look back the PowerPoint that I have. I have my number of success is 538 from the prompt, 538 and 943. So I put it in 538, 943 is really the number of observance, which is n. And here you have 0.5. Actually, we don't have 0.5. We have some other value. What is it? We have P naught is 0.63, 63%. And here is decline, right? So we go to less than, decrease, and compute. So when you compute, you have this value. See that? So exactly what we have. So if you run StatQuant, you can copy down this section for step 1. Step 3, you can copy down the standard error and the z-stat. And for step 4, you compute p-value, which is you let me know the p-value. So this roughly like a 0. And then you draw a conclusion. Since this is less than 1%, if I set up my alpha is 1%, this is less than 1%, then we have to reject the null hypothesis, which is we disagree with the population proportion is 63% that support the death penalty. So let me go back to PowerPoint so that you can see clearly the conclusion. So we got the exact value. And here, this is the slide that teach you how to use TI-84 calculator. You just follow this step, then you got a solution, exactly like you do it for StatQuant. Right here, they give you more option. Like, so it means we're done with the example 2 that I just draw a conclusion for you. We have to reject null hypothesis, which is we disagree with the null hypothesis. And right here, this is another case. So let's say we're done with that example. Now, if the case with 2 tails, then that's gonna be look like. So this means you will find a p-value on the left, and on the right, you add these 2 together to get p-value. But you don't have to worry about this because StatQuant do it for you. When you run StatQuant, they give you the value. And the next picture is talking about the left tail area. They're using less than notation. So which is this? The alternate hypothesis, this will be the notation that you have to put on your step 1. And this slide is another case, case 3, talking about the right tail, which is the p-value will stay on the right side. So for this one is another example. This example talking about increased library funding. This look like we are having a number of success. When I skimmed through this, I noticed that 140 would be my number of success, and 250 would be my my n, my sample size, right? So when you run StatQuant, you will enter 140 for number of success and 250 for the number of observance. So let's see, when we read along with this, we have the keywords say more than. More than is talking about greater than, right? The notation greater, which is the right tail. And 50% here will be your P naught, right? So favorite increase, another word, keywords is increase, talking about the greater sign. So funding for public libraries. Then this time they given us the level of the significance is 1%. So now we're going to compare after we run StatQuant. You will compare with this 1% so that you can draw a conclusion and interpret the question. Here will be the steps. And remember, it's on your task. You need to write down the step like this. And like I said again, you don't have to write step 2 for me. You can skip step 2. For step 1, hypothesize. You need to point out this and that. To me, I would like to write down the alpha equal to 1% so that later I will know to compare my p-value back to alpha. So when they run StatQuant, like you see that, I magnify this for you. Number of success will be, they enter the number is 140, and number of observance will be 250, and P naught will be 0.5. You have to enter the notation greater than because the keywords is increase or more than, and then you click compute. You have this data. So you know this, you need to write standard error. For me, in step 3, z-stat is 1.897 in step 3, and p-value in step 3. So after you found this, you compare with 1%, which is step 4, and then you see this p-value is greater or less than 1%. Is greater, right? So it is greater than the alpha. So we do not reject the null hypothesis, which is we agree with the null hypothesis. So that's how they write step 3. So you have to recopy all your data in step 3 again by looking at StatQuant. So here the conclusion, here the interpretation. So in this case problem, we were given a significant level as 1%. So our p-value is 0.0289. It's greater than 1%. And so we will not reject the null hypothesis. What does it mean? It means we cannot conclude that the majority of voters support increased public library funding. It looks like we reject the alternate hypothesis, correct? So we're done with A part 2. So see you again in A part 3.